we're going to take a look at common factoring. So what I'm going to do here, we're going to put a quick example out. So we can even use the first one they have here. They have 4x plus 5xy, okay? Now this equation isn't equal to anything at the moment, right? We don't have anything equal. And part of the reason they've probably done this is because they've used the x and the y here, and we're used to seeing things as x and y, but it doesn't matter. I could say this is equal to a. If it helps me stay a little more organized for my common factoring, I could say a is equal to this. We can use any letter for a variable. Mm-hmm. The goal here is they've stated they want us to common factor. So we're going to take a look. Common factoring deals with being able to read an equation relatively well. So anytime we have like an operator, that's a plus or a subtraction sign, that separates two terms. So really what you have is two terms here. And you're trying to find commonalities in these. Actually, I wrote that number wrong. I'm going to change that number. I mean, it could be 5, but we're going to do 6 just so we can get a little more practice at this. We're looking for commonalities between these two values. Essentially, some factor that is the same in each of them. So what we can do is we can split this up. Even though this is a term, this is actually some number times some variable. And this is some number times some variable times some other variable. And then you could just keep stacking variables on here, okay? So it could be really long. What we can start with is the numeric values. These are the coefficients in front of the variables. So have you ever looked at, it's called a greatest common denominator, something like that. It's where you find factors of two numbers. So I would use 4 and 6, okay, to start. And I just write out all the factors. Well, factors of 4 are 1, 2, and 4. Factors of 6 are 1, 2, 3, and 6, right? And depending how large the number is, that will be easier, or it could be much harder, like finding all the factors. The greatest common denominator is a number that exists in both, and it's the largest one because there could be more than one. Yeah. For instance, 1 is a common denominator of absolutely every number.
But
okay.
2's bigger. Yeah.
2's bigger. Do we have any others? No. Okay. So here's our first trick. What we know is we're going to end up dividing both of these terms by the value of 2. This is part of common factoring. We're actually dividing out. Okay. Next thing we have is the variable x. Okay. This is technically x to the power of 1. And it's x to the power of 1 in both of them. So this happens to be the same.
Yeah.
If this was different, we'd have to take the one with the lowest exponent. For instance, say there was an x cubed out here also.
Yeah.
Okay, let's say I'm going to add it in just for the sake of argument. We had this x cubed. Well, then if I was a common factor, I could only take x to the power of 1 or x out of everything. I can't take the largest. I have to take the smallest one. Okay, now in this case, we won't do that because it's going to change our original stuff. But we're just going to take x out. So in other words, x is another common value. That x is out of here. And y only exists in the one term.
Yeah.
So because it's not in both, I can't take it out of both. So it's not common between the two.
Yeah.
So actually our common factor is just the number 2x. So if we say a is equal to, next what we do is we write the common factor, and then we write a set of brackets. We're still going to have our two terms. There's going to be like a plus sign, or if we divide by a negative and that changes the operators. What we do need to do is figure out what's left over.
Yeah.
So we have to carry out some division. 4x divided by 2x. So we can again split these in terms of their like terms. So 4 divided by 2,
2.
that gives us 2. X divided by x,
Just cancels out.
yeah, they cancel. Technically they create a 1 and it would be 2 times 1, but
Same.
that doesn't change anything. Exactly. So we'll leave it as 2. Then we go to the next term. 6 divided by 2,
3.
that gives us our 3. X divided by x, same as before, cancels out, and we're left with the y. And this is it. I mean, it's a little spaced out because I wasn't sure what I was going to get, but if I were to rewrite it again, I'd say 2x and 2 plus 3y. And what we've now done is we've common factored this. So this is a factored form of it.
Yeah.
Okay.
So which means like if you